So moving on, the fourth one in terms of model diagnostics is called as error assumptions. So whenever we build a multiple linear regression model, right, so if you remember the equation, let us say y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus so on and so forth up to beta p xp plus the error term, right. So there is always a error term in the regression equation. So this error is assumed to be a random variable, right, and further explanation as we move along, as we go along, I will inform you, right. So this is your explained variance. The first part is basically your explained part, right. Whatever is the variation happening in y is being explained by these independent variables, whereas whatever is not explained, which we call it as error term, right, which is basically unexplained part. So now whenever we build the regression model using a sample data, we take few assumptions on this error term and then build a estimated equation which does not include the error term, right. So the estimated equation will look like something like this without the error term. So what happened to the error term now? Now to account for that, we have taken some error assumptions. Every statistical techniques have got some assumptions. Likewise in a regression we have got the error assumptions. Later whether those assumptions are valid or not, we need to check. That is basically called as residual analysis. Moving on, if you can imagine there is one dependent variable and one independent variable, let us say x is your independent variable and y is a dependent variable. Essentially we have these data points and then we are trying to get the best fit line, right. So that is your regression line, right. So best fit line is what we are getting. So now what is the error? So if these are the sample data, if you look at, take it, right. So these dots are your sample data and this is the estimated regression line, then difference between this line and to the point, right, and difference between this line this point and to the line, right. So this is called as the error, right. So ideally all the points situated on the regression line, then that is a very much best fit line, but usually there will be a difference. Overall if you look at it, if it is in and around the regression line, then we are doing a good job, right. So this is a simple understanding of the error term. So with this understanding we will move forward. What are the assumptions we have taken the error term, so that we can happily forget about error terms and estimate the model and then revisit whether the assumptions are valid or not. So these are the four assumptions that we have taken about the error term from the regression model. The first assumption is the error term is a random variable. So random variable means every sample will take its own value and with a mean is equal to 0. So that means what? Sometimes the error will be positive, sometimes the error will be negative. As a whole the average will be 0, right. So that is the assumption. If it is a random in nature, if the error is random in nature, if it is induced error, then obviously it will not be 0, but here we are assuming that it is not an induced error, it is a random error and hence it is called as a random variable, and positive errors will possibly cancel the negative error and hence null effect will be 0. The second one is the variance, right. So any distribution, there are two things which is important, one is average, other one is the variance, right. So variance basically says you about the distribution, variance slash standard deviation, right. So standard deviation, when you square it becomes a variance. So instead of saying standard deviation, which is deviation from the mean, we always refer it as a variance, right. So variance determines whether the data is densely distributed or it has got a skewness, so on and so forth, right. So in this case what we are trying to assume here is if the deviation of the data points from the mean is more, then the standard deviation is more. If the standard deviation is more, then there are so many outliers. So that means there might not be a linear relationship exists between the independent variable and the dependent variable, and hence to account for that, what we are saying, all these things are based upon the error assumptions, right. So variance of the variance denoted by E, right. So the variance of the error term denoted by sigma square is same for all values of independent variables, right. So, the independent variables so has the equal variance with respect to your error term is what it is referred as. So, which we call it as homoscedasticity assumption. Why it has to be variance has to be equal? If the variance is not equal, then the estimates that we get is also will not be correct, right. So, it will be biased, and the standard error also it will manipulate, and as a whole model cannot be trusted, which we call it as a model misspecification. So, that means the regression model is not useful, and hence the variance has to be equal, in this case uniform, right. And the values of E, that is error terms, are independent. So, for any sample if you take the occurrence of the error for one sample should be completely independent of the occurrence of the other sample, right. If they are related, what does it mean by both the samples are in one way assuming the same thing, or they have induced it, right. So, sample people who have responded possibly have influenced each other, something like that it gets. So, that means what, whenever I am filling the questionnaire, whenever somebody else is filling the questionnaire, the error values are independent. The error induced, the measurement error we call, is basically independent of each other, that is the values of error terms are independent of each other, independence error. The fourth and final one is, we say the errors are normally distributed random variable, right. So, why normally distributed random variable? As you know, in a standard normal, mean will be 0 and standard deviation will be 1, right. So, in this case the standard deviation 1 is what we call it as a homoscedasticity, which is the equal variance. So, it is normally distributed also says that the positive error will cancel the negative error. So, after remembering all the 4 things, right. So, you can summarize like the values of error terms are independent, normally distributed with the mean 0 and constant variance, right. So, normal distribution we say as standard normal distribution we say as mean is equal to 0 and standard deviation is equal to 1. So, here we call it as a uniform variance, or what is called as constant variance, right. So, this is the very important thing related with error assumptions. The values of error terms are independent, normally distributed with the mean 0 and has a constant variance. So, this is the assumption on which we are building the regression model. Now, since we have taken an assumption and building the regression model, after we run the regression model and get the estimated equation, now it is imperative that we need to check whether the assumptions are violated or not. How do we check the assumptions? First, let us understand the difference between what is error and what is residual, right. So, of course, we need to check the validation of error assumption using something called as residual analysis. Before proceeding further, let us try to understand what is residual, and then next slide I will tell you what is the difference between residual and error, then we will go for validation technique. If the assumptions about the error term appear questionable, right. So, if any of those things, that is the errors are independent, normally distributed with the mean 0 and the constant variance, if any of these things is violated, then the hypothesis test about the significance of regression relationship and the interval estimation may not be valid. So, in essence it cannot be used for further prediction. The residual provides the best information about the error, right. So, understand error is related to population, right, but essentially we do not have a population data, whatever we have is a sample data. Put it otherwise, what is the objective of statistics? The objective of statistics is to understand about the population through sample, right. So, I am trying to understand about the population error through sample, right. So, in the sample data is what I have population data I do not have, right, and the error is I am getting through what is called as residual, right. What is residual? The difference between the actual value, which is represented as yi, minus the estimated value is the residual, right. Residual is nothing but the estimate of the error term, right. So, that is how residual and error are related. Residual is a terminology we use only for sample, whereas error is the terminology we use for population. What is the objective of statistics? Understanding the population through sample. That means if the residual follows or follows the error assumptions that are taken in the initial, then it can be understood the error assumptions are validated, right. So, we check the error assumptions through residual because this is the data set we have. Residuals provides the best information about the error E. So, this is a parameter and this is a statistic. So, residual for observation I, as I said, is given by actual value minus the estimated value. Yi is your actual value and this is the predicted value or estimated value, right, that gives you a residual. So, if the actual value and predicted value is almost close, then your residual is 0, which is the ideal case that we want. In that case, all the sample data will lie on the regression line itself. So, much of the residual analysis, right. So, whatever assumptions we have taken, how do we check? There is not necessarily separate formula to check that, but most of them are understood based upon the visual representation. We will see that. So, now we keep on using this term error and the residual, right. What is residual? What is error? Residual is the thing that is related to the sample, error is the thing that is related to the population. Residual is the estimate of error. If the residual follows the assumptions, that is validates the assumption, it is understood error assumptions are also validated, right. So, let us spend some more time on understanding error and residual. Error term represents the way observed data is what? Your sample data differs from actual population, which is your population data, right. So, that means error term is related with the actual population data versus the sample data. Residual represents the way observed data differs from estimated data. Observed data again is sample, estimated data is actually what we have estimated from the regression equation, which is represented as y hat. This sample data is always represented as yi, population data is represented as y, right, or capital Y if at all you want to call it, right. So, error is what? Error is the difference between the observed data and actual population data. Usually actual population data is not available for us, whereas in terms of residual, it is the sample data versus the predicted data, which is yi and y hat.